Hi, welcome to today's lesson on ionic bonding. One of the things we have to do is um, go back and change the date. I made this video the other day thinking we were going to do this all on Monday, but I decided that was not what I wanted us to do. So ionic bonding will start today, uh, Tuesday the 31st. Okay. In the previous video, you should have copied down this charge sheet, and you may have had this in your periodic trends packet. What you're going to need for today's lesson, obviously your notes, a periodic table, and I think that's it. All right, so if we're going to call this 331, we'll call this easy ionics. So we're going to get to today, essentially, how do you write a formula? Like why is water H2O? Why, how'd the two get there? Where'd it come from? Why is table salt NaCl? Why isn't it Na3, whatever? So we'll go through a couple of examples, and then I'll give you some to try on your own. So for these easy ionics, we'll do the examples, then we'll list the steps. All right, so example 1 for today. And remember, you can pause this video at any time to keep up. This is kind of what we would cover in the classroom, but, I'm not stopping all the time, to check stuff, to make sure you guys got it. So that you guys can do on your own by just pausing the video. No one's raising their hand asking to go to the bathroom. I'm not telling anyone to put their AirPods away or stop eating, Meshack, things like that. So our first example is lithium. Let's do lithium bromide. All right. So some things you might notice with this, with lithium bromide, is the ending has changed from ene, bromine, to bromide. So when I give you the example, what you're going to do is, the first thing is you're going to write the symbol. So I have lithium, and I'm going to write its charge as an exponent. So lithium is in group 1, and its charge is 1 positive. And then we have bromide, which is the element bromine. And bromine is in group 17, so its charge is 1 minus. Eventually, you guys are going to have these charges memorized. Okay? And then when we look at the charges, we add them up. Plus 1 minus 1 gives us a neutral charge or a zero charge. So when the charges are the same, plus 1 minus 1, plus 2 minus 2, plus 3 minus 3, when the charges are numerically the same, all you do is you drop the charges and you write the symbols together. That's all you do. All right, let's try another example. Let's do example 2. Let's do barium sulfide. All right, so we have barium sulfide. Pause the video if you need to keep up. All right, so barium, just what we did in the previous example, we wrote the symbol and we wrote its charge. Barium, find it on the table. Where is it? It's in group 2, so its charge is 2 plus. Sulfide is really the element sulfur, so sulfur's an S. Now sulfur's in group 16, so its charge isn't a 6. If you look back up at the table, sulfur's charge is in group 16. It's a 2 minus, because it's what does it need to become stable? All right, so sulfur needs 2 more valence electrons. All right, now I look at my charges. +2, -2. They're the same charge. So we're going to cancel them out, and we're just going to write our formula. Pretty easy, right? In terms of ions, the first one, this is written as, what does it have? It has 2 valence electrons. This one, the charge is written as, what does it need? It needs 2 more. So the first one, our cation, our positive ion, is always going to be written as, what does it have? The second, our anion, is always going to be written as, what does it need? Have, need, have, need. All right, let's try another example. Okay, so think of it in terms of, what does it have? What does it need? Example 3, let's do aluminum nitride. All right, and in using the strategy that we listed above, okay, so this strategy right here, aluminum, we write its charge in terms of, what does it have? And nitride is, what does it need? Okay, so take a moment and find aluminum on the periodic table. Aluminum is Al. And how many valence electrons does it have? That becomes the charge. It has 3. All right, next we have nitride, which is really the element nitrogen. So the ending, the "ide," it gets changed when it enters into an ionic compound. All right, so see if you can write the ion for nitride. Okay, nitrogen is in group 15, so what does it need to become stable? It needs 3 more valence electrons. Our charges are the same, so we just drop the charges and we write the symbols together. I think some of you might pick up on this pretty quickly. So I'm going to give you a few examples to try on your own, and they will be the first things that are checked tomorrow. All right, so here are the examples that I want you to try. I want you to write the formulas for, let's do example 4. Let's do sodium chloride. Example 5, let's do calcium oxide. Example 6, stick with aluminum. Let's do aluminum phosphide. Okay, so try these 3 on your own and show all the work in your notes. Don't just do it in your head. Write every step down. Show the ion, write the charge. Show the ion, write the charge. Okay? Try not to peek at your charges chart. So if you can't remember what oxide's charge is, look at your periodic table first and then scroll back in your notes to the chart. All right, and this will be the first thing that we check tomorrow. Thank you.